Okay, sac209 number 1 is an electric circuit problem. We've got C to VMF and a resistor. The C to VMF connected directly across the terminals of the resistor. C to VMF maintains a potential difference between its terminals of a given 6.30 volts. And the resistor is a poor conductor having a resistance given as 222 ohms. And what we want to do, first let's recognize that the longer bar is the high side of the electric potential. So I've drawn it with that at the top. As a result of that, we'll have some charged particles that are going to be flowing around this circuit. They fall down from the high potential through the circuit to the low potential, and then they get lifted back up again as a result of a chemical process occurring in the battery, if it is a battery. That'll make this the high side of the resistor. And this is an Ohm's law problem. We can write down Ohm's law as V is equal to IR, where Ohm's law is V is equal to IR with R being a constant. And what's nice about this one is that the voltage in this case is just the voltage of the C to VMF. Remember, in applying Ohm's law, you can't use any old voltage. You have to use the voltage across the resistor that this R characterizes if you're, for instance, attempting to determine the current through the resistor. Well, in this case, check this out. We got only two perfect conductors in the problem. This one and this one. And the potential difference between these two conductors is the potential difference between the terminals, these 2 points, of the C to VMF, because this yellow conductor is connected to this terminal, this top plate of the C to VMF, and the red conductor, ideal conductor, is connected to the negative terminal or the bottom plate of the C to VMF. So the potential difference between the red and the yellow conductors is 6.3 volts, just the given V. And looking at the resistor, here's one terminal of the resistor, here's the other. This terminal is at the potential of the red conductor, and therefore the potential of the bottom terminal of the C to VMF, and this terminal is at the potential of the yellow conductor, and therefore at the same potential as the potential of the top of the C to VMF. So the potential difference between the terminals of the resistor is the potential difference between the yellow conductor and the red conductor, which is the potential difference between the terminals of the C to VMF because of the way things are connected. So the voltage that we've got here is also the voltage across the resistor. One might say the voltage across the resistor is equal to V, which is the terminal voltage of the C to VMF. So this is an easy problem. It is important, I'm stressing it in this easy problem, to recognize that you can't just grab any old voltage and use it in Ohm's law. You have to establish or determine that voltage, which is the voltage between the terminals of the resistor, R appearing in Ohm's law. And we've done that, so now we can just go ahead and solve for the current. That's what they wanted. Find this I through the resistor. It's given as V over R. Well, maybe I shouldn't say given as, but we find it to be V over R when I solve this equation for I, dividing both sides by R and then switching sides. So now it's just a plug-in. I'll go ahead and substitute the given 6.30 volts, proved to be the voltage across the resistor, and I get 0.02837 amperes for the current, which can be rounded to 0.028, it's this digit, 4 amperes. It's important to note that this 0 is just a placeholder. It doesn't count in determining how many sig figs. We've got division going on up here, so the answer is supposed to be quoted to the number of sig figs, and that value which has the least number of sig figs, they both have 3, so I got to quote it to 3 sig figs. I've gone ahead and done that there, and I choose to slide the decimal point over 3 places, equivalent to multiplying by 10 to the third, and at the same time multiply by 10 to the minus third, quote that as 28.4 milliamperes, which is the